Here's a box with a right-handed coordinate system. That means x crossed with y has a direction of z in the right-hand sense. Here's a three-dimensional force, 200 newtons. What does it look like? Does it look like that? How about those two? How about that one? All four of these are described by the same vector. All four of those forces have an x-directed force of 2 and a 0 directed force in the y and a 0 directed force in the z. All four of those forces are described by the vector 200. Now let's look at another example. Each one of those forces has a magnitude of 3 newtons. How do you express it as a three-dimensional vector? There's no component in the x direction, so that's 0. There's no component in the z direction, so that's 0. There's only one component, and it acts in the y direction, and so the y component of the force vector is 3. Here's one more example. What does the force 0, negative 4 newtons look like? Any one of those, the magnitude of the force is 4 newtons, acting in the negative z direction, all four of them. There's no component in the x direction. There's no component in the y direction. The force totally acts in the z direction, in the negative z direction. That's why the force, all four of those, is described by the same three-dimensional vector, 0, negative 4. Now let's find three-dimensional torque. Define a right-handed coordinate system and the size of the box. 2 meters in the x direction, 3 meters in the y direction, 4 meters in the z direction. The origin is at 0. Attach a force, 0, negative 5 and 0 newtons, to that edge of the box anywhere, doesn't matter. That's called the line of action. The force could be attached at any point along the line of action for the purposes of this calculation. Let's draw a radius vector from the origin to some point along the line of action. X is 2, y is 3, is one vector. We'll go from the origin to a point on the line of action. Therefore, the torque about the origin is R cross F, and the answer is 0, negative 10 Newton meters. It can be done with the TI-89 calculator as well. There is the TI-89 function that will calculate the torque about the origin. Torque by inspection is also possible. 5 newtons times 2 meters is 10 Newton meters in the negative z direction by the right-hand rule.